Now, before we go too deep into the subject, I just want to have a general discussion. When I say discussion, obviously there is no two-way discussion. It's going to be me talking to myself, really. And I ask, why CAD? Digital design eats CAD these days. Everything is, if you're working for a supplier, a designer, anywhere in the supply chain, you are expected to know this language, and this is a universal language. And you may ask, why are we learning CAD? Well, there are lots of reasons why we need to learn CAD. This is what actually makes an engineer an engineer. If you are well versed with the spoken language, and here it's a simulation language, this is how engineers talk. For example, the technical drawings you're going to work with, that is your formal communication. If you imagine the modern day and age where companies are based in different countries, probably none of them speak the same language, it is necessary for you to have a universal mode of communication. And that's where the technical drawings come into play, because people understand technical drawings. It's on piece of paper with all the dimensions, all the manufacturing instructions, and it's not gray. It's there, black and white. So it's such a valuable skill that you need to gather that as soon as possible through this module, and we'll be testing you on that. Okay, so why do we learn CAD? I think because it allows you to speak that language, which allows you to communicate above the line, below the line, etc., sideways, all the supply chain, etc., and also the ability to be able to learn how to read someone else's drawing. If you're not generating anything, probably you want to be able to read and understand. Maybe you want to redesign something someday. Also, I think CAD is very friendly. It is very 3D, very visual, easy to understand. Hence, it has become the currency, a norm across the industry. No matter where you go these days, gone are the days where people need to sit down and draw everything manually. And 2D and 3D, everything is done on computer these days. That's why we're doing computer-aided designing. Okay, we have within every CAD software, it can be any CAD software, and they're all pretty good these days because of the rising computing power. You have huge choice of processing, huge choice of materials. You can generate, you can design something, you can simulate the machining process, you can design something for turning or milling, etc. So you can have all of that knowledge built into a CAD model, which I think is pretty exciting. It makes it a really, really powerful tool. Also, it shows that you're competent. You know what you're talking about. You know the entire design journey and the manufacturing journey, and you are incorporating that in your drawing. Okay. CAD, obviously, it's a prerequisite for CAM. CAM means computer aided manufacturing, and it is also a prerequisite for rapid prototyping. I'm sure you have heard of these terms. Okay. CAM, it's if you're using a CNC, so it's a numeric controlled machine. If you're using that, you're generally expected to have a CAD model that then feeds onto the CNC, which will machine a component for you. Don't want to bog you down with too many details, really. I'm sure you know what rapid prototyping or 3D printing is. All of that needs sufficient knowledge of CAD to be able to do that job. And I think CAD gives you that stepping stone to be able to go to CAM or RP. Okay. It is also a step between your design and computer-aided engineering. So sometimes these days, it's considered the norm now, before we manufacture anything, because manufacturing is a resource, it's a very valuable resource. We can't be wasting it. So every time we manufacture anything, before that, we test it out. So you make a piece of metal, we test it out in a virtual environment to see if it is strong enough, if it's big enough, it is going to sustain the pressure, the stresses of the operation. This is called computer-aided engineering, where we model something and we then apply real-life loads in a simulation scenario, and we see how our artifact functions. If it's behaving correctly, then it's fine. If it's not, we go back to the drawing board, not literally drawing board, go back to the CAD software, and then we redesign it to be able to accommodate for those changes or design against the weaknesses. Okay, this clearly saves us a lot of money, resources, and this can be automated. This process can be repeated a number of times. Imagine if you're designing something, sending it off to a manufacturer to manufacture, only to find out something wasn't right or the wall thickness wasn't correct. And then you realize, okay, I should have made it a lot thicker, or I should have added some ribs or webs to be able to apply some stiffness. You can do all of that before manufacturing. within the computer, okay? And that's called CAE, Computer Aided Engineering. Second last, motion simulation. That's such an attractive feature within most of the CAD packages these days. Obviously, well, I'm going to talk about the one we're going to use eventually. Motion simulation, it's such a pleasurable thing to work on, where you actually model a part and model the neighboring part, and then you can actually study the articulation of these parts with respect to each other. It gives you an idea in terms of how big the part is going to be, how you assemble something, how you can design the packaging. If something is moving, something's not rigid, then most of the times you want to be able to morph it and see what is the smallest and biggest it will get to be able to design the packaging around it, where you need the cushioning, where you need the supports, and so on and so forth. So you would need a competent CAD software, and obviously the skills to be able to model the motion, to be able to design the packaging. Also model motion to be able to learn and study the kinematics of how does something function. Is it going through itself, which is obviously not possible, working on a linkage mechanism, and so many other simulations. In electrical, you can also work on some of the simulation before we send it all of this to manufacturing, okay? And lastly, because everyone else is using CAD, that's one of the reasons why everyone must speak the same language, okay? I hope that's enough about the reasons why we're studying CAD or digital design. Okay, see you on the next session.